In order to understand how neural network training works, it's important to have a good understanding of loss or a cost function. And that's what we are going to cover in this video. As usual, we'll go through some theory first and then we'll implement different cost functions in Python. And at the end, we'll have an interesting exercise for you to work on. So let's get started. In this deep learning tutorial series, we already built a neural network to recognize handwritten digits, and if you have followed that tutorial, you will realize one of the parameters that we use while doing model compile was this loss function here, and that's what we are going to talk about in this video. So moving on to our presentation, you can specify different values for this loss function when you are building a Keras or a Tensorflow model. We use sparse categorical cross entropy, but there are other possible values such as binary cross entropy, categorical cross entropy, mean absolute error, mean squared error. Now, in our machine learning tutorial playlist earlier, we have talked about mean squared error. So we are going to look at these two, mean absolute error and mean squared error, really quickly by using the example of play card. Let's say you and your friend is playing the play cards, okay, and your friend has 3 play cards that you are not aware about, and he asks you to make a guess on what those cards are. You will make a random guess and say the first card is 8, the second is queen, and the third one is 6. Then you will ask your friend how accurate your prediction was. What he will do is he will tell you the error that you made in each of the guesses. One way of finding that error could be the absolute distance between those 2 cards. For example, the distance between 8 and a king is 5 because after 8 comes 9, 10, then jack, then queen, and then king. So total 5. Similarly, distance between 6 and 7 is obviously 1, and queen and 9 is 3. So the total error that you made was 9, and the average error would be 3 because 3 cards, 9 divided by 3, you know, simple math, 3 is the mean error. This is called mean absolute error. The other way of finding the error would be the squared error, where you take the error and you do a square of it, and then you take an average of that square. So here the mean squared error would be 35 by 3. One might ask, why do you need to do square? Well, in neural network training or in general in machine learning, having squared error has some utility. It allows your gradient descent to converge in a better way. Now, what is gradient descent? What is convergence? We'll look into all those parameters later on. But for now, just assume that having squared error is useful in many occasions when you're talking about machine learning. So what does loss has to do with respect to neural network? That's a question that this grumpy cat is asking. And the wise dog is saying that it is used in neural network training. So loss is heavily used during neural network training, and we'll look into exactly how it is used. So we'll go back to our standard insurance dataset example. If you are not following this tutorial series and you're stumbling across this video randomly, I would suggest you watch all the previous tutorials in this deep learning tutorial series. We have talked about this insurance dataset multiple times. Here you have age and affordability, and based on that, you're trying to predict the person will buy insurance or not. You see sometimes person with 47 years of age and he has affordability, so he will probably buy it. Affordability simply means if the person can buy the insurance or not. If you're earning 10,000 rupees a month, and if I ask you to buy insurance of 9,000 rupees a month, your affordability will be 0 because that's too expensive. But if you're earning 10,000 and if I ask you to buy insurance of 500 rupees a month, you'll probably buy it. Okay, so that's what that is. Now here age and affordability is X and having insurance is Y. These are also called independent parameters, and Y is a dependent parameter. And in machine learning, all you're trying to do is come up with a prediction function, which is y is equal to f of x. It's as simple as that. And we have seen this picture before. This is logistic regression, where based on age and affordability, you calculate the weighted sum and then you apply sigmoid function. Again, we have covered all of this in our previous videos. So guys, if you have not watched it, I would suggest you pause this video and watch those awesome tutorials so you are not afraid of all this mathematics. This is all very easy math, trust me, if you've seen previous videos. So here, the name of the game is to figure out W1 and W2. So what happens is you go through your training set. This is supervised learning, so you go through your training sample one by one. So you take 22 and 1. Then initially you try to start W1 and W2 with some random weight. So right now I'm initializing W1, W2 to be 1. It can be 0, it can be random values. You're just making a random guess. So we initialize W1, W2 to be 1. And then we feed the first sample into our neural network. We are now talking about training. And then we find the outcome. So y hat is used for predicted output and y is used for the actual output. Your actual value is 0 here. See, having insurance is 0. But your y hat is telling you 0.99. So it is obviously making an error. So you try to find the error. One of the way of finding this error is mean absolute error, which is just a absolute difference between these two values. Similarly, you take the second sample, you feed it to your network. It's called a forward pass. This is a very simple single neuron neural network. Again, you calculate the error. This is error number 2. We have total 13 samples. So eventually you will get at the 13th sample, you will have error number 13. And then you will accumulate all those errors. So this is the formula. It is like sigma I is equal to 1 to n absolute yi minus y hat. All it is doing is summing up all the 13 errors. And the sum that comes up, you take a mean or an average of it. It's called mean absolute error or MAE. Here, the mean absolute error is called cost function, and the individual errors that we are getting, error 1, 2, etc., it's called loss. Now, sometimes people use loss and cost as synonyms, but as per Andrew Ng, individual errors are called loss and the cumulative error or the mean absolute error is called cost function. So here my mean absolute error is 10.02, and once I go through all the training samples, once I finish the single round of forward passing all the training sample, it is called one epoch. So one epoch is going through all the training samples once. And if you remember from our model.fit, one of the parameters that it had was epoch. So epoch was 5. So let's look at that. You see here, we did 5 epoch, which means we went through all the samples 5 times in total. So mean absolute error is something we already looked at it. There are other type of errors as well, such as mean squared error. And if you want to specify that, you will use this particular parameter, mean underscore square underscore error. And this error is same as mean absolute error. The only difference is that instead of taking the absolute difference, you take a square of that difference. And again, this has a value. It allows your gradient descent to converge in a better way. We will look into the details later, but this has a utility. The third type of error that you have is log loss or a binary cross entropy. So you might have seen that in model.compile, sometimes people use binary cross entropy, and binary cross entropy is a synonym of log loss. And this is the formula for log loss. Now, you can just accept that this is the formula. I'm not gonna go into details of how I came up with that formula, because then it will make this tutorial very long. But if you're trying to learn machine learning, sometimes you have to just accept the mathematical facts. It's like why pi is 22/7. Well, it's a mathematical fact. So similarly, this is the log loss function. Do not worry too much about these mathematical equations. This is for your understanding. You don't have to go too much into detail. I mean, of course, if you're interested, you can go and figure out why this equation is like this. But this is what binary cross entropy means. Now, for logistic regression, we use log loss. We do not use mean squared error or mean absolute error. In our presentation, I used mean absolute error just to keep it simple, but in reality, practically for logistic regression, we will be using mean, not mean squared error, of course, but the log loss or binary cross entropy. And for that, I'm gonna link a nice article on Towards Data Science. The link of this article is in video description below, where Mr. Rajesh has explained why we choose to use log loss for logistic regression. Okay, so just go through this awesome article, you will get an idea. But overall, what we're going to do now is we will implement all these different loss functions like these three in Python, and then we'll have an exercise. And the reason we are going to go through all of this is because the loss function is used in neural network training. So in future videos, we will implement neural network from scratch. So it will be important for you to understand log loss, because ours is a logistic regression and we will be using log loss or a binary cross entropy. So let's get started with coding now. I have launched Jupyter Notebook and I have y predicted and y true values. I have two NumPy arrays where I have total 5 samples, where the first one is the predicted value and the second one is the true value. And I'm going to first implement the mean absolute error function. So I will say def mean absolute error, and there will be two parameters, which is y true and y predicted. Now, as we saw in our equation before, that mean absolute error is nothing but the absolute difference between your true values and predicted values, and then you take a average of that. So it is very simple. So what we can do is we can go through both these arrays. So first I will define this total error variable, and then I will run a for loop on two arrays. Now, how do you run for loop parallelly in two arrays? Well, you can use zip function. So you can say for y true, y predicted in zip. So zip is y true and y predicted. So it will give you one value from both of these arrays in each iteration. I mean, you can just print, if you want to just be sure, we can just print these values initially to see how it looks. So MAE will be y true, y predicted, and you can see that it just iterates through the true value. So it took 0.3 and then 1, 0.7 and 1, and so on. So pretty simple. Now the absolute difference between these two will be, in Python there is a function called ABS. So y true minus y predicted, this will give you the absolute difference, and then you can add it to total error in each iteration. This is how you add it, and then once it is done, you can say total error is total error. And then if you want to get a mean, you can just say, okay, MAE is equal to total error divided by the length of an array. Now both the arrays have same length ideally, so you will say length of y true or y predicted, doesn't matter, and then you return that. So when you calculate this, you get total error to be 2.5. So here what I will do is I will also print the mean absolute error. So mean absolute error is MAE. I mean, we have printed it, but just to make it more fancy. All right, now here we use Python's for loop, but actually the reason NumPy is very popular is it allows you to do vector operations very easily. So now we will define the same function using NumPy, and NumPy makes it extremely easy. So if you want to take absolute difference between the two, see, when you do y predicted minus y true, if you're NumPy array, you can do something like this, okay? And this is giving you the real difference. But if you want to have absolute difference, you can do this, okay? And mean absolute error is the absolute difference, and then you just take a mean of it. So you can just do np dot mean. See, 0.5. This was so easy. If you want to get total error, you can do np dot sum. It will give you 2.5, which is a total error. But the same function, this whole function, we did it in just one line. So you can realize how powerful NumPy is. All right, now let's implement the log loss or binary cross entropy. Mean square error will be an exercise for you, so you guys will implement it, but I'm gonna go ahead and implement binary cross entropy. Here we are using log function. Now you need to know certain things about log function. For example, when you do log of 0, for example, it is not defined. So whenever you have log 0, what you need to do is you need to take a value which is very close to 0 but not 0. So for example, if I do, let's say this, that is fine, and that is very close to log 0. So in our function, when we define this binary cross entropy function, we have to replace 0 with a value which is very close to 0. Also, look at this formula, 1 minus y hat. So first of all, we are taking log of only predicted y value, not the absolute value. And we are taking a log of predicted y value plus 1 minus y value, which means if you have 1, for example, if you have 1 in a predicted value, that will also create a problem, because 1 minus 1 will be log 0, which is undefined. So the first thing that you need to do is come up with epsilon. And by the way, friends, we are implementing all these loss functions just for your understanding. When you're using Keras or Tensorflow, these things are done for you. But if you have in-depth understanding of how these loss functions work, it could be very useful during interviews. If you're applying for machine learning position or data scientist position, having this understanding of inner workings will be extremely useful. You know, in the interview, they might ask you to implement log loss function. So that's why it's very important to go through this code. So let's say my epsilon is 1 e raised to minus 15. This is like, you know, like so many 15 zeros and then after 1. So I will first define epsilon like this, and then the y predicted that I have. See, what I'm trying to do is, if I have value 1, I want to replace it with a value which is close to 1 but not 1. So what is the value which is very close to 1? Well, 0.9999999. Similarly, I want to replace 0 with a value that is close to 0 but not 0. And what is that? A value like this. So let's do that. So first, so I will say y predicted new, okay? And I will go over all the values in y predicted. How do you do that? So for I in y predicted, we are using something called a list comprehension in Python. And I have separate Python tutorial series if you want to know more about list comprehension. So here each I will be the value of each value in y predicted, and what we want to do is we want to take a maximum between I and epsilon. Okay, so what did it do? So it replaced the value 1 with a value which is very close to 1. So this value is nothing but like maybe 15, 0 and then 1. Okay, and the second thing I want to do is I want to replace 1 with a value which is very close to value 1. So here you will do min between I and 1 minus epsilon. So epsilon is value which is very close to 0, like a very minute value, and when you do 1 minus that, you know, you get a value which is very close to 1 but not 1. So you see, now we got this value, and again we are doing all of this because log of 0 is undefined. Okay, and I converted this y predicted new to an NumPy array. It was a Python list because we use list comprehension, and when you do the log of this, see, you get some good values. If you do just the log of the original y predicted, see, you got like this infinity value which was not good. So that's the reason we created y predicted a new NumPy array. Now here we are going to type the formula for log loss, which was this. So log loss is nothing but yi into log y hat I plus 1 minus y into log 1 minus y hat I, and you sum them together. So this is how it is. So np.mean is the minus np.mean is this guy minus 1 divided by n and sigma, and then remaining thing is very obvious, y true into this plus whatever. You can verify the formula, and then you get this log loss. So here I have put everything in one single function, and this will be a log loss function. These are the instructions that we looked at above, and I have just put them into a nice function. And when you call this log loss function for y true and y predicted, you will get okay, epsilon is not defined, so epsilon I will just say 1 e raised to minus 15. See, you got the same value, 17.26. Alright, now comes the most interesting part of this tutorial, which is an exercise. So you guys are all pro in loss function now, and you are going to implement a mean squared error function for me. You will use it in two ways. First, you will implement it without using NumPy, and after that you will use NumPy, and you will realize how easier it is to implement loss function using NumPy library. There is a solution link here, but you're not going to click on it until you solve the problem on your own, because I have a coronavirus embedded in this link. If you look at this link directly without trying on your own, that virus will come to your computer and it will delete all the files. Okay, so I have that magic, so be very careful. So I hope you like this tutorial. If you are enjoying this series so far, please give it a thumbs up. I'm gonna put this notebook along with exercise and solution, everything on my GitHub. The link will be in the video description below. So always check the video description. I provide ton of useful information in that video description. All right, thank you very much for watching. Goodbye.